So what I've done here to help with this process of trying to streamline this is to go to each of the EnRoute files, and here we have a different folder for each particular model of car. In there we have an ROU file. That ROU file contains different parts that are going to be cut. So what we've done is taken each specific part, converted it to a DXF file, and the DXF file is going to have two layers. One layer will contain the actual part, and the other layer will contain the label. Now it seems like somewhere during the export process I have a little issue to address, but when we do this, we will make sure that we have the text on one layer converted to curves and the cutouts on a separate layer. All right, so now we're going to go here and do that for each of these parts. And any place I had a duplicate, so where I had two of the exact same part, I just created a single DXF file, and we'll use a quantity of 2 when it comes time to cut the parts. All right, so that's the process here. So what we've done is at the end of doing this is we have a folder here with all of our model or our car numbers, and we have DXF files, some for 1mm material, some for 1.8mm material, and each of the ones that gets 2 parts, I put an X2 here just to remind myself I needed a quantity of 2. I also put the material in the DXF file name, which doesn't have to be there, but I did that just so I'd be able to make it easier to recognize when I was making lists and things. All right, so each one of these folders has different DXF files in it. Then what I did is I used the cut list creator program in EnRoute, this ATP file setup, and I had to get rid of all of the dashes and a few spaces, but get rid of the dashes to allow this to work. That allowed me to create 2 different files here. These are comma separated value files. Now an XML file could be used to provide this information and not have CSV values. And we're going to have to figure out the best way to create these text files, because this particular text file represents a day's jobs. So what it's going to have is it's going to have a link to the DXF file location. So we don't need all the DXF files to be together. They can stay in their folder. The cut list file will just link to that location. And part of this information here is a order number that I've entered just manually. So I think there's going to be a process of wanting to be able to generate these automatically and not manually. And that's not going to happen with EnRoute. That would have to be some third-party programming that would create this list file for you. But here I created 2 list files. One of the jobs is a 1.8mm job, and the other job is a 1mm job. So the 1.8mm refers to all of the 1.8mm DXF files in these folders, and the 1mm points to all the other ones. And when you use that tool, when you use this tool to create your own cut list for practice, you actually basically browse to the location, and then you hit add, and you can create a whole bunch of parts that you've added, and you can add some details here about them. At the end of the process, it creates on the C drive a file called ATP files, and then you have to rename it to what you want it to be. And the ATP files don't have the correct path file, so you have to add the C:/ to each of the front of each of these. So there was a little work I had to do. I also manually added these order numbers, which is not part of this one, but I had to come in here and manually add it after the material, and that's how it shows up in the list here in a second. So there was some work to do, converting everything to DXF files and naming them properly, and then figuring out how the cut list will be created. Once you have the cut list and the DXF files, then the process of using EnRoute AutoTP is a little easier. So we're going to come here to AutoTP. Boxster is my program I'm going to use, which is an internal EnRoute program. I'm going to first load my 1mm material. This is all the information about it. Then I'm going to load my job, and this is going to be Solor 1mm open. This lists all the part names and the thickness, the material type, the unit number, which could be an order number or whatever you want it to be, and the quantity. Each of these in the 1mm material gets 2 of them. All right, whether it can be rotated or not, how much it can be rotated, and I actually want to change this to 5 degrees. If it's not, it is 5. So, you know, this is something you wouldn't have to go through and change any of these variables. They would be set. We're going to call this SP test, and then we'll let the rest of it appear automatically here. And now we're going to output it to the Solor P location. All right. And we're going to do a layer printout, do labels, and create the output file. So I'm going to hit Process Boxster. And using the selected driver setup, which is the multicam driver, it's going to create output. Now this is going to be the layer printouts, and I'm printing, normally you'd print directly to a printer. In this case, I'm going to print the PDF. So we're going to call this SP test 001. We'll call this layer output 001. Normally you wouldn't have to name these, but I'm going to do this here. I'm going to do this SP test layer output 002. And if there was 3 or 4 or 5 sheets, you know, if I'm going to have a PDF be my printer, I have to name each sheet. Otherwise, if this was just pointing to a printer, they would just start printing up. Then you wouldn't have to name anything. So now we have two sheets here. A material, we have this particular part here, and then we have, this is our second sheet. As part of the process, we created the output files, the CNC files, and we can come here and take a look at those with Backplot or the Multicam job editor. And that's going to allow us to see the actual part there. Well, looks like my auto toolpath. All right, so here's our layer printout, and then we would also have the label files, and then we printed up some printouts. So let's go here and sort these by date. These ones at the very bottom, these are just some test files I was doing, so I can get rid of those. These are the ones I just printed out. So here's SP test layer output 1. And when I hit OK here, this shows me I've got eight different jobs on here. Now, you know, I group these two together as one part. And here you can see part 6 and part 1. These are related to 2 different parts that I did as a single piece. If we wanted to separate those, we could. I was just kind of not sure if they would be or not. Sometimes you might, if you had 2 parts that fit together really well, you might want to do a pairs nesting instead of nesting a single part. And so that's kind of what I did here. I nested these 2 together as a single part. All right, so we might break those up and get a little better result. Then we can output layer 2, and this shows us which parts were on layer 2. Now, as I said, in addition to that, we have some label output. So I'm going to go to the EnRoute auto toolpath, labels, and let's go to the label maker here. My printer, again, is PDF. So I'm going to say open. All right, we're looking for the label job design file 001. We're going to call this label 1mm 001. I'm going to go here to the second job, which is the label 002. So what you would do after a job is you would print up the labels for each of the parts on the piece. Then after the job is done cutting, let's go back here to the desktop. After the job is done cutting, you would print up the particular labels that go on a particular layer. And when you run the job, you could actually attach the labels to the layer printout. That way, when you run that particular job, you'll see where each of the labels go. And we can take this label off of here, and it shows us where it is. It shows us where it is on the given part. So, so here, this particular part that gets this label, which is order number 103, and this would tie into your ordering system. Then you can put this label here. And you can put this, the number 10 here would go on this part. And so the person, before they remove the pieces off, would put each one of these labels on the part of that particular layer printout before pulling it off the sheet. So, you know, during this process, we've made it easier to just pull a bunch of jobs and not have to actually look at the jobs, but the list file will point to each of the DXF files and would be able to keep things together here. Now, I'm not sure. Let's look at the layer printouts again. So let's see here. I'll actually make it a little bit more information by looking at this label here. So this was 103 on the front, 104. So it didn't really keep it by a lower order. So these parts are not necessarily being kept together, but it would allow you to have a slot where you'd have X amount of jobs you're running at a time, where each particular job, you know, maybe you'd have 15 or 20 jobs you'd run at once, and you'd have a bunch of slots, and then as you pulled it off the table, you would put the part in its appropriate slot to get all the pieces together. So, you know, there are techniques for working with this, even if they're not all together, to be able to get all the pieces necessary together. So, anyways, this has been a way I've been able to, using DXF files and creating my own cut list, to do layer printout and kind of automate the process. So, to where if you had 50 jobs a day, once you created the layer printouts, the rest of it would be automatic.